Hello, everyone. Welcome to the Enology webinar series. My name is Andrea Bottasato. I'm with Texas A&M, Texas Agrilife Extension Services. Today, we will be talking about high pH winemaking. Before we begin, just want to say I'm really excited to see what an international crowd we have today. People from all over the world. Welcome, everyone. Thank you for attending this. I don't know what time it is where you're at, but I suspect in some places it might be very early morning or very late evening. So thanks again for joining us. Before we begin the presentation will take about 50 minutes to an hour. There will be a Q&A session at the end. Please use the chat box or the question box to send in your questions, and we will do our best to answer them. Also, very important, please, before you leave the webinar at the end, please do fill out the survey that will pop up. It's really helpful for me. It helps me keep this series going. It only takes 1 minute of your time. Even if you've done it before for other webinars, it's really important that you keep doing it. I thank you and appreciate the time that you take for doing that. And now, without further ado, let me introduce the presenter today. He is Mr. Luke Holcomb of Scott Labs. He is a friend of our program and a supporter of our program. Thank you, Luke, for being here today. You will be talking about strategies and solutions for high pH winemaking. So take it away.
All right, thank you very much. Thank you to Texas A&M for having me. This is, I don't know, I think maybe my fourth or fifth one that I've done. This one is focusing on high pH winemaking. So in my territory that I cover, this includes Texas, New Mexico, Arizona, Colorado. Those are places with hot climates and high pHs. So it's particularly important for me to understand some of this stuff. We have at Scott Labs not only enological projects to support high pH winemaking, but also the technical expertise to back it up. So I'm very thankful to be here and to be a guest. Hopefully this is informational. Normally when I give presentations, it's at conferences and seminars, and it's really nice to read the room. So webinars are always interesting because if I tell a joke, I'm hoping people are laughing on the other end. I have no way to verify that, so we'll just dive into this. I'm going to keep this fairly high level and not get too down in the weeds on really specific technical information. This is kind of an umbrella look at high pH winemaking. I cut my teeth in winemaking in the Central Valley, a lot of Lodi fruit, and so got to deal with high pH on a large scale, about 30,000 tons a year. So some of the stuff that I'm talking about today wasn't actually available at the time that I was doing that actively. So there's a lot more tools in the toolbox. So we're going to talk about some of those, and if there's any questions, my contact information is on this slide as well as the last slide, and you can also run things through Andrea as well. So we'll just dive into it. So, I always like to set things up with, well, why are we concerned with this? I'm assuming that there's people on this webinar that come from all different backgrounds, all different levels of technical understanding, and also different philosophical approaches. So, some people are very much on like the commercial side of things where they want very consistent wines. They're comfortable using all the tools in the toolbox, and then there's people on the other side of things that want to really let the wine make itself and be non-interventionalist. I don't think that there's a right or wrong answer there, so I'm going to try to kind of shoot the gap there and discuss that. Also, I think generally one of the trends in the industry is to move away from using sulfur dioxide as a preservative, as a enological tool. And while I think that's well-intentioned, it does create significant problems, especially in high pH winemaking. So in general, I'm going to talk with kind of the pH ranges we're working with, 3 to 4. I know in Texas and some other places it can actually creep above that. But in general, this slide presents kind of the the gamut that we're working with, but on almost every category, high pH wines are more sensitive, more fragile, shorter shelf life, less stable. It's whether it's protein stability, bacterial growth, all of these things. So you take a look at the slide, you can see that colors if affected, oxidation is affected, bacterial growth. Oxidation is one of my primary topics that I like to talk about because it is such a huge issue in the industry worldwide. It's the #1 defect, and it drives a lot of other spoilage and degradation. So I'll talk a little bit about that like I do in almost every presentation. If you want more information, we can get very technical and very deep down in the weeds. There's multiple presentations online, as well as some articles that I've written. So if you want some of those resources, please feel free to reach out for me after the presentation. So I like to really think about winemaking from a risk assessment standpoint. I'd love to see some sort of algorithm developed where it looks at all of the different factors from a chemistry and biological standpoint to give us kind of an index on risk assessment. So which wines are more stable than others, and you would plug it in and see a number generated to give you a guide. And some of this winemakers know inherently, but it would be nice to have a numerical data set for that, i.e. if something was low alcohol and high pH and hasn't been through malolactic and has some residual sugar, it has low tannin structure, that would be one that would have a higher risk assessment versus something with higher alcohol that's been through malolactic and is dry, so on and so forth. But the other way to look at things is from a timeline. Where are the critical control points in a wine's life? Because you can really get down into the details with winemaking, and you want to parse through where can I have the biggest impact, where are the biggest risk concerns, where do I have the least amount of control, and what do I focus my resources, whether it's time or money, on. So this is sort of the flow diagram of what we're going to be looking at today, starting with vineyard practices down the list all the way to packaging. So this is an overview, and each one of the slides will follow this this guideline here. So I'm a big fan of writing a HACCP plan. If you're unfamiliar, there's a lot of information on the web about what a HACCP plan is, but essentially it's hazard analysis critical control point. And this is super common and is of great importance in food production. Winemaking and alcoholic beverage production gets something of a pass to an extent because the fact that we have things like pH on our side, alcohol on our side, fermentation's a kill step, so on and so forth. However, the methodology behind a HACCP plan can be utilized to improve and maintain the quality of wine that we produce. And really what it is a way to critically look at the process and focus on prevention as opposed to reaction. So preventing problems before they occur as opposed to reacting and trying to go back and reverse engineer where the problem came from. So I'm going to talk about some of the places that I think, especially in Texas, where I think there's some critical control points that if we focused on them a bit more, I think we could have a very big impact with the least amount of resources. So I'm not going to focus too much on products. I obviously this is what I do for a living, and the company I work for, Scott Labs, we have a wealth of fermentation, enological products as well as packaging, equipment, filtration, and so on. But this is including some of those, but also focusing on the practical applications of winemaking. So we all know the catchphrase that great wine starts in the vineyard, and I'm a big believer in that. So when it comes to looking at what's happening in the vineyard and how to plan out your harvest, sometimes you can have small modulations during the year and the growing season, and you have small reactions to that. And then some years you may have to take things a completely different direction. So instead of making a dry red wine, it may be best to make a rosé with the fruit, just because of what's happened in the growing year. So some of the things to look at are a rot assessment and mitigation. Now, I'll be the first one to tell you I am not a grape grower. I am a fermentation person, a winemaker. So I'm not going to get too specific on these, but you do want to have some sort of assessment in place to look at the rot incidents, especially before it's picked. In Texas in particular, there's a lot of mechanical harvesting, and so while that can pick around some rot, I think it's very important to have some analysis out in the field to look at what the rot was to begin with before it's picked and sorted on these onboard destemmers and sorting systems that some of these harvesters have. Mitigation, this could be a spray program. This could be looking at, the index for rot. UC Davis has a good system. And also working with consultants and your friends and figuring out what works. There's a lot of folks in the industry worldwide that are using fruit contracts to specify the parameters around how much percentage rot you can have, maybe even levels of glucuronic acid, looking at tonnage per acre, the chemistry, what minimum bricks you need to have, for example, and also material other than grapes. So that's something that can be worked with in the vineyard and also on the crush pad, and can really have a pretty big effect, not only on wine quality, but also the processing efficiency on the crush pad. The last thing you want is to have something come through your line and potentially, jam your pump up or blow a press bladder, so on and so forth. So it's an important consideration. One of the tools that we have in our toolbox is Lavinia. This is an autolyzed yeast product that is used in the vineyard on the grapes. And you can see the description there on the right-hand side and a testimonial from Todd there at Brennan Vineyards in Texas. It really has a number of effects. From the application in this standpoint, what we're looking at is it does have an impact on rot percentage as well as skin thickness and elasticity, and essentially can help make the fruit riper at an earlier date, which can have some really good effects for the winemaker. So I'll show you a slide here in a minute just to give you a visual example of what this can look like. But it's a pretty safe product insofar as it's not a chemical, it's not your typical spray. So it's something that I feel doesn't cross too many philosophical lines in the vineyard. So if you are trying to do biodynamic or organic, you definitely need to check the regulatory concerns. But or if you're trying to move in that sustainable model, this isn't a chemical spray, cooked up in a laboratory. So that's one of the nice things about it. You should also discuss sanitation expectations with your grower, with your harvester, all those sort of things. And then also, the trucker themselves on what the expectations are on how long it's going to take, what temperature the grapes should be shipped at, how they should be shipped, so on and so forth. Harvest determination, I think this is probably one of the most important decisions in winemaking. When I was in California, we really had a lot of opportunity to take fruit when it was ready, rather than pick around the weather so much. When I was making wine in the Midwest, sometimes you had to pick based on saving the crop versus ideal chemistry. So sometimes you're dealt the hand you're dealt. Other times you can dictate it depending on your growing region, what sort of control you have over the vineyard source, and so on and so forth. But I think in general, anything you do in winemaking, the earlier you do it, I think the better, and especially goes with grapes. The sooner you have these conversations with your grower and how you're going to mitigate things, the better, just so that you can have some semblance of a plan moving into harvest and make small adjustments as opposed to trying to figure out everything in a very short harvest window. Real quick, this is a picture of what grapes can look like with and without this La Viña treatment. In talking with the winemaker that got these pictures for me, the fermentations on the treated side kicked off a lot faster than the ones on the left. And anecdotally, what we came up with was that the overall microbial load was a lot less on the treated than it was on the non-treated. This particular grower and winemaker uses it prophylactically on everything. She's in a difficult growing environment with high humidity and working with hybrids. So, but I think, a picture's worth 1,000 words, so this one must be worth 2,000. So that's just a good quick look at that. So when we're talking, this critical control point timeline, it really starts at harvest and also before, like I mentioned. I'm a big fan of ATP swabs and ATP testing. I think that they're very simple, they're very repeatable, and it gives you a quantifiable number to look at what level of microbial load you have. So I know some, harvesting companies, they will actually verify their sanitation procedures with an ATP swab and say, look, this is how many CFUs we have. This is, we did the sanitation procedure. Here we go. Now the harvester's clean, just like a winemaker would do on the bottling line. So this is something that I'd like to see more widespread usage of, because it gives you a quantifiable validation of your sanitation procedures. But at the beginning of harvest, hopefully everything is clean, and what happens throughout harvest with the schedules and machines moving around different vineyards and timelines and weather events, sometimes sanitation can take a back seat in high pH regions, especially when there's machines going between vineyards that have different levels of inherent microbial load. I think the sanitation and verification of sanitation procedures is really, really important and can help mitigate and validate some of the problems that can happen, and help you figure out if there was a problem, where it did happen. So testing of the, for example, the fruit belts on the harvesters, the picking bins themselves, the destemmer and the sorting belts that are online, all those kind of things can be something you can look at. From a grape transport standpoint, here's a picture of a refrigerated truck. They're loading the bins on there. The bins themselves, obviously, because they're in contact with the fruit, they're important to be of good, clean and low microbial load. Again, ATP testing is a way to validate that. But also the trailer itself, you're moving that air all around the trailer, and we are dealing with microorganisms that can be airborne. So if you have a trailer that's got a really high microbial load and you put good clean fruit on it, you could be inoculating with a spoilage organism. And another step here is making sure that you have good control over the bins that you're using, and that there's some semblance of a protocol on how to clean those, what the expectations are, and again, using ATP swabs as a way to validate that and set some parameters. So some of the tips, with any sort of cleaning, sanitation, sterility program, those are the 3 steps. First, have to be visually clean. So you could have something that's visually quite dirty and use the strongest sterilant or sanitizer on it, and if you can't break through that soil layer, you really can't impact what's behind that layer. So you first have to do a general clean. Now, this looks something like elbow grease, or maybe a product like Destainex, which has some surfactants, chelating agents, kind of the scrubbing bubble effect to help break down that organic material and expose the surface behind the organic material, so that you can then sanitize. And if you decide to try to sterilize, you can do that. because you could take ozone and spray down the entire trailer, but if you haven't cleaned it first, you're really not doing near as much as you could. Should go without saying, but avoid materials such as wood and cardboard. One of the issues is not only halogenated aerosols like TCA, which tend to are very prolific in wood and cardboard materials, but they're also almost impossible to clean. So I think generally speaking, if you can stick with things like food grade plastics and stainless, it's much better insofar as a picking bin or transport bins, things like that. Other non-ferrous metals, I have seen gondolas that are fiberglass, or they are a ferrous metal, and then they're coated with some sort of food grade coating. If that's the case, you do have to make sure that paint or the coating is fresh and not degraded, because there can be some leaching that occurs, especially on non-ferrous metals. Avoid use of chemicals containing bleach, and I think this is really something that the winemaker has to really work hard at. When you talk to non-winemakers and even people in food production, they rely heavily on bleach, which for something like apples or fresh fruit, it's very, very common to use chlorine-based sanitizers. However, with winemaking, we're very concerned, especially with TCA, not to mention other halogenated aerosols. So when you're talking chemicals and cleaning and sanitation, I think it's a good thing to focus on not using chlorine-based sanitizers. The other thing I'd like to talk about are some of these tools that are fairly new in the industry. And this is non-Saccharomyces that can be used. It's non-fermentative. It is a biological alternative to something like SO2 for bioprotection. We'll talk about this a little bit more, but I do have quite a few people in Texas specifically using this. This is Mechicovia fruticola, and it was isolated out of a cold soak and was initially used for bioprotection during a cold soak. From that point, it's moved into even holding juice through harvest for mute, and also in high pH applications for fruit transport, where you're using a microorganism to help protect the fruit, the juice, the transport, instead of sulfur dioxide. Now, this is probably a review for a lot of people, but I really want to point out how important it is. Sulfur dioxide is one of the most prolific antimicrobial and antioxidant preservatives that we have in the industry. It works great in many situations. However, I think that there are some important points that need to be fleshed out. I see a lot of things online and in forums and Facebook groups where people say, oh, 30 parts is fine for knocking back a bacterial load or something like that. And while dose is important, dose has to be taken with a grain of salt, and that grain of salt is pH. So in general, most winemakers, or historically what has been taught, is something between 0.6 and 0.8 molecular SO2 is where you achieve a good amount of protection from an antimicrobial standpoint. When you look at what it takes at some of these higher pHs as far as a quantity, it starts eclipsing the sensory perception threshold of sulfur dioxide, and you can pretty quickly get into a legal limit issue where you can have too much total SO2 to actually be legal. So, if you were dealing with a Tempranillo that was 4.1 and you said, hey, I'm going to hit this 0.6 or 0.8 molecular, and you're over 100 parts per million, you don't have a lot of room to make subsequent adds at that point. So, most people, grape growers, are working in the 30 to 50 parts per million. They'll just go ahead and prophylactically toss it in the bin. If you were in the 3.3 and lower range, I think that's an adequate number that is known to help prevent microbial growth. But at the higher pHs, I don't know that you're really doing yourself a lot of favors. Also, when you're working with higher pH whites and reds, you are worried about phenolic extraction. So if you add something that has sulfur dioxide in it, or just sulfur dioxide by itself, you're not getting a whole lot of antimicrobial protection, and you also could be getting some solvent activity of SO2 on pulling out some of the undesirable phenolics. This is especially important in things like Roussanne and Viognier, but I would say Viognier in particular. You can be pulling out some of those compounds out of the stems, perhaps, or the skins, and maybe even the seeds. Depends on how clean the fruit is that you're going to have to then deal with on the winemaking side. So I'm not against using SO2. I just think it needs to be used correctly and with a clear understanding of how it interacts with pH. Using Gaia as a bioprotectant, it's non-fermentative, so it's not going to kick the fermentation off. You have much lower levels of volatile acidity. A lot of the anecdotal testimonials I have from customers using this is that their VA numbers, this is speaking in Texas in particular, their VA numbers across the board went down significantly, and I have a slide to show that as well. It's reducing the population of spoilage organisms, not from like a sterilization standpoint, but it's inhibitory. So you implant a known strain of this non-Saccharomyces, and it overwhelms the indigenous population of these other spoilage organisms to keep them from proliferating. It also can have a positive impact on mouthfeel and aroma from some of its enzymatic side activities. So Gaia in particular secretes the K2 toxin. Now this is not toxic to humans, but it is in the microbial world, it is inhibitory to other spoilage organisms. One of the ways that I like to explain this and how I like to think about it personally is from my years in college with botany. There's a process in which, especially in like arid environments where plants are trying to compete, especially for water, you'll notice that a lot of plants and trees, they'll start growing, and as they mature, their root ball area, the area of the ground where the roots are, it's devoid of any other plants. And what's happening is the plants through the roots are excreting compounds that inhibit other plants from growing, thereby eliminating those other plants from competing for water. So this is similar, and it can reduce the respiration activity of other microorganisms, can lower intracellular ATP, and can it actually in some cases can cause ATP to leak out of the other cells, which is ATP is the fundamental energy source for all life. And it can also cause a decrease in cell viability. So this is why it's so powerful in a winemaking standpoint. It has pretty good SO2 tolerance. What you do have to follow this up, as with a lot of non-Saccharomyces, with a fermentative yeast to continue the fermentation. But this image here is showing the parameters of looking at acetic acid production, and they had some pasteurized samples that they were looking at. This was in a controlled environment, and you can see the levels of acetic acid here. And to me, it's quite shocking because you have contamination with Cloacara, which is one of the most voracious spoilage organisms on high pH fruit. And even with a contamination with Cloacara, you add the Gaia in with it, you have lower VA numbers than you would even with a non-contaminated control. So, if VAs are an issue in your region, this is something that you can use to help mitigate that. I've heard a lot of people say that, with mechanically harvested fruit in high pH regions, that by the time they receive the fruit at the winery from the grower, it's already fermenting. And sometimes, that's not a bad thing necessarily. Maybe it's a good Saccharomyces strain that's doing the fermentation, but oftentimes it can be something unwanted. So with that in mind, I've had very good success with this. A lot of clients that are using it with very good success as well. when the fruit does show up, I think one of the biggest things to do is fruit reception and fruit sorting. So in general, with climate change and some of the parameters around growing, there's really high Brix levels, but sometimes the phenological maturity lags behind it, and the wines tend to have a lot of alcohol, but not a lot of phenological maturity, and some of the methoxypyrazines and the green notes that can be exhibited are pretty apparent. So one of the ways to mitigate that, is Lavinia in the vineyard, but from a fruit sorting standpoint, can be removing the unwanted jacks, leaves, mog, and some of the stems that can come through even after it's been mechanically harvested through something like a phenolic, where it has onboard destemming and onboard sorting. Using something that takes that sorting to the next step, I think has a very good application. This could be an optical sorter. This could be a sorting belt, and where you have people pulling things out as the fruit is moving along the reception line. There's also roller sorters, which is what's pictured here. This is a double roller sorter, so it has two different stations stacked on top of one another that will remove things like ladybugs and small bits of leaves and stems and things like that. And that really can help clean up the fruit. The other thing that it does is it gives you an opportunity to separate the juice that was in contact with the fruit during transport, which among other things helps you manage your phenolics. If you did have some fruit that was compromised and there was some rot issues, a lot of the glucuronic acid and some of the other negative compounds, VA potentially, are going to be sequestered to a large extent in that juice. So if you're able to pull that juice aside, you can take the rest of the fruit and process it separately, and then you have control at that point to do some back blending if you choose to. And I'm actually going to talk about this from another standpoint of having sort of like tiers in your winemaking program where you're pulling the fractions apart, whether it be at fruit reception or during pressing, and having different programs that you handle separately. Really gives you a lot of tools as a winemaker. At this stage, this could be a good point to use enological products such as tannins, enzymes, things like that to allow more gentle processing of the fruit without as much maceration, maybe even bypass crushing, which is good for high pH applications. So the tannins can also, improve structure and inhibit the lactase enzyme. I think from a philosophical standpoint, a lot of times I try to think about things from building a wine up at the beginning as opposed to trying to pick it apart downstream. So this is the difference between using a tannin on the fruit stage or at the reception stage versus using a fining aid downstream post fermentation to try to pull out, phenolics or maybe aromas that are not very nice aromas to have. So if you can do things by early and by building the wine up, I think that is a gentler, more holistic approach than trying to pull something out down the road. This picture didn't show up very well, but this is a destemmer, and let's see if we can see it. This is on a crush pad after harvest, put away for the season, and this is just the one end of the harvester. This is indicative of the whole destemmer. This is just not clean. Not only is it not clean, it's not sanitized, and it certainly isn't anywhere near sterile. So, when I understand, I've worked on crush pads, this can take a lot of time and elbow grease, but beyond just the particulate matter, you can also kind of see on the stainless here, there's this film. Now, some of that's tartrate, some of those are proteins, but certainly in there are a lot of microorganisms hanging out. So you can really develop a large amount of bacterial and spoilage organism growth there that beginning of the year may not be such a big issue, but as harvest goes on, that load can get bigger and bigger and bigger, and you can really have some pretty significant issues here. So I'm a big fan of sanitation and spending that time on the crush pad, and we'll talk about that here in the next slide. So sanitation is key, and especially on processing equipment, it's important to remember that your best quality fruit goes through that line and your worst quality fruit goes through that line. So depending on the order of which things come in, you can have a lot of cross contamination. And I know for a lot of people this is probably review, but I think it is good to revisit it. You know, you can have elevated risk of stuck fermentations, higher chance for wine faults and flaws. I know some winemakers that when they received the juice, they already had mousiness before they even started fermentation. So sometimes in those applications, it doesn't matter how clean your processing line is, but so just to say that this kind of stuff can happen really quickly. And you know, you have to focus on the things that you have control over. And one of the things that you have control over during harvest is the sanitation procedures that you use on your crush pad. Again, like I said, I think it's worth the time and expense to go through and really clean and validate procedures. Again, this is a place where an ATP tester, you know, you say the crush pad is clean, the destemmer is clean, the pump's clean. You can use an ATP tester to go out there really quickly for like $2 a test and have a validation number to know whether or not it is. And this is a way to validate procedures and make sure that, you know, maybe you have different shifts at the winery to make sure that each shift is doing it appropriately and correctly, not as a, you know, pointing the finger at one shift or one person necessarily, but just as an overall quality control program. One of the things I like to do during pre-harvest prep and then also post-harvest is really take a hard look at the pumps and the hoses. So even with a properly assembled hose, which I'm not going to get into, but there are properly assembled hoses and ones that are not. For example, if you're using a worm drive clamp that you got at the hardware store to secure your hose onto the hose bib, that is not proper. And you're probably gonna have issues not only with hoses popping off if somebody closes a valve, but also it's a really big entrapment zone, that layer between the interior of the hose and the exterior of the hose barb. So if you notice on this hose right here that I'm pointing out, one of the most common areas that you'll find a hose fail is right at this bend in the hose. Incidentally, if you do take the opportunity before and after harvest to go through and cut the ends of the hose off and reassemble, shorten the hose just a little bit, not only do you have a chance to sanitize the fittings and remove any of the microbial load, the biofilms that certainly have developed, you also take care of this bend region in the hose. This is a stress area that's very common, and that's where you typically will have leaks. So it kind of gets you, it's a twofold activity there. You're cleaning things, but you're also preventing hose failure in the future. So it's a double benefit. Pump maintenance is, in my opinion, probably one of the most significant sources for spoilage in the wine industry. If you look at dairy operations and other fruit and food processing operations, before and after every single operation, the pump is completely disassembled, sanitized, allowed to dry, and then reassembled when they're ready to use it. That is very uncommon in my experience in the wine industry, and I've taken pump heads apart with customers, and you know, you'll have it just reeks of VA and biogenic amines and all sorts of things, really high populations of bacteria. So in in high pH applications, I think this is super imperative. Now, not all pumps are created equal, whether you have a flexible impeller or a Waukesha, or maybe different types of Waukeshas from different assemblers. This can affect how clean they are inherently and what you need to do in order to sanitize them. If you have a progressive cavity pump, for example, you're probably not going to be able to take it apart and physically clean it, so you'll have to rely on some sort of passive cleaning agent. So this is really one of the most important places, I think, in the crush pad and in the winery that needs to be focused on. Another way I like to think about this is during harvest, when you have a lot of juice and fruit, potentially with some indigenous spoilage organisms in it. Once you're done with harvest and you're starting to move your wine and your juice and things into various stages that have better stability, i.e. post-primary fermentation, post-malolactic, if you're using the same pumps and hoses on that stuff without doing a deep clean, you could be reintroducing a lot of these populations that came in from the juice stage. So important to consider what you're doing. For fermentation, I think yeast strain selection is super important. There are some newer strains on the market that can have good applicability in high pH regions. For example, this graphic relates to a strain that we have called Ionis. It is known to naturally acidify the must. It also can help lower the alcohol content, so it does not produce as much alcohol as perhaps another strain. And you can also see here, in this particular case, the reference yeast had a pH of 3.75 post-fermentation, Ionis at 3.66. So this is, I think, a tool in the toolbox. I don't think anything in winemaking is a silver bullet, but if you, potentially you could use something like Gaia in the transport, and perhaps Ionis during the fermentation, a little bit of acidulation, all these things to help move that needle downward insofar as pH. You can also consider a strain that has a killer factor. If you know you're getting fruit in that is compromised and has a high spoilage organism population, there are strains that have known killer factor, similar to the Gaia that has the K2 killer factor, but it essentially will help sequester and prevent the growth of those spoilage organisms, as opposed to some yeast strains that don't have that activity. So that's one of the things that you can do when you're looking at picking a yeast strain, is picking a yeast strain in these high pH applications that do have killer factor. That it's one more tool in the toolbox. For example, there are some strains that are known to produce more SO2 during fermentation than others. So this is another one of those factors that can help keep the populations of other spoilage organisms at bay. So again, here's another non-Saccharomyces that's commercially available. It's Lactantia thermotolerans, and it produces lactic acid. So 1 gram of glucose, it'll form about 1 gram per liter of lactic. Now, you do have to be careful because more than 3 grams per liter of lactic acid can inhibit malolactic bacteria, so you do want to be careful, but this does produce some alcohol as well. But you can use this in combination with some other tools and help somewhat more naturally control the acidity. It does consume quite a bit of organic nitrogen, so it is important to supplement, and you do need to follow it with a fermentative strain to finish the fermentation. So with pH control, there's a lot of discussion out there on high pHs and what the root causes, whether it is climate change, whether it is the soils that it's in, potassium content. I think hang time is also a very important thing, and some of the parameters that winemakers are looking for with higher Brix numbers. And I think generally, as growers across the world have gotten better at achieving higher Brix, sometimes the phenological maturity hasn't kept pace. So we're trying to get those hang times to improve those phenolics and get those higher Brix numbers. And as we do that, the pH tends to increase. And sometimes we're working in pH regions that really difficult to work with. Above 3.6 is kind of 3.6, 3.65 is kind of a break point for me. So acidulation pre-fermentation is a very common method. I think it has very good applicability. Each wine's going to have a different buffering capacity. I know some winemakers that have, especially in Texas, that have thrown many grams per liter of tartaric at something and not seen the acidity stick. So it's a tool in the toolbox. You kind of have to do some testing on your own to figure out what is going to work. So one of the nice things about it, even if you don't get the pH shift that you want, that's persistent, you are moving things and you are moving the pH around, and that does help to control some spoilage organisms. So even hitting it, right there at the maybe even at the harvester or in the transport bin or even at the crush pad, using some sort of acid to move the pH down, that's going to help knock back that indigenous population of microorganisms. Generally, what I find a lot of people like to do with white wines, they try to mimic the acid profile if they're not going to put it through malolactic. So generally that's 2/3 tartaric, 1/3 malic. That makes the math a little tricky, but I think it helps mimic the what's coming in from the fruit. And red wines that are going to go through malolactic, most people use a tartaric to do that. So what's a good pH to shoot for? Myself and I think a lot of other people are of the mindset that 3.55 is a good number to shoot for, maybe even a little bit lower than that. And the argument against it is, well, your TA is going to be a lot higher potentially. And this day and age, there's so many enological adjuncts and methods and materials to manipulate mouthfeel, whether it's from cap management or different yeasts, different yeast derivatives, sugar even, to manipulate that mouthfeel. So if you do have a TA that's high and it's a little tart, there are ways to manipulate that mouthfeel. And I would personally rather get the the pH below that 3.6 in the 3.55 range. The reason 3.55 as opposed to 3.6, for example, because 3.6 is sort of the break point, is that pH meters and probes, depending on their age, the quality of the machine, how it's been calibrated, even a properly calibrated pH probe and a high quality one at that usually has a precision of like 0.05 pH units. So if it's reading 3.6 and you've achieved this pH, it could actually be 3.65. So this is why I move a little bit further on what I consider the safer side, 3.55. That way, plus or minus 0.05, I'm still in, I think, a pretty good range. And when you are considering acidulation, you can use the math that's in a lot of the texts, and for example, 1 gram per liter of tartaric should move the pH down by 0.1 pH units. Very rarely actually occurs. So when you are calculating a pretty good size add, I know a lot of people like to have the theoretical add and then usually hit somewhere between 75% of that add just to see what the actual buffering capacity is. So bench trials are always recommended, and even when you scale up, sometimes it's not indicative of what actually happens in the cellar. So talk to your winemaker friends that have done this if this is your first time, and see what's working with other people. If you're sharing fruit, maybe buying multiple wineries buying from the same grower, talk to the other winemakers and see what they're doing and what sort of adds and how they do it and when they do it. And see and work together. So during fermentation, before you kick it off, I think you really should measure the yeast assimilable nitrogen and make prescriptive adds as opposed to prophylactic. So I know at least in Texas, usually the YANs are really high. However, YAN is the combination of organic nutrition as well as inorganic. So your amino acids plus your ammonia. However, yeast are a complex organism and they need, other things other than just inorganic. So something like just DAP. If you crank your YAN number up using DAP, you're only giving it part of the picture. And we know now that many of the positive aromas that we are looking for in wine are driven through amino acid biosynthesis. So this is one of the reasons why historically people have said, well, if I use DAP, my wines are a little harsher, not as aromatic. But if I use something like yeast hulls or an organic nutrition like Fermento, the aromatics are better. Well, this is one of the reasons why, and there's now organic nutrients on the market that are specific to certain kinds of aromatics. Something like Stimulus en Blanc is going to drive thiols. Stimulus Chardonnay, for example, drives ester production. So the YAN number is super important, but it's not the whole picture. And prescriptive adds are very important because if you just make a prophylactic add and you're not countering what's actually in the fruit to begin with, you can have a lot of leftover nitrogen that can be used by spoilage organisms post-fermentation. So you kind of want to create that nutrient desert that some people refer to. So after malolactic, you've consumed the malic acid, you've got a dry wine so you don't have as many fermentable sugars in there, and now you remove the extra nitrogen. So the spoilage organisms have less to grow on. You're trying to make their lives as difficult as possible. And by doing non-prescriptive prophylactic adds, I think you're putting yourself in an area that you can run into some issues. So on the right hand of this slide are some of the flaws and faults that are common in high pH wines. Apart from a general trend in the industry to try to get away from using sulfur dioxide, there's also an interesting push to also go quote unquote natural, although that doesn't have an actual definition yet. Some people have started to, but essentially it's using whatever indigenous microflora are there to conduct the fermentations. One of the reasons we have commercially available yeast and bacteria and the variety that we have was we learned throughout the thousands of years that we've been making wine that the indigenous microflora can sometimes do a great job, but oftentimes causes a lot of problems. And so we've isolated out of nature these strains that we know are doing a good job. For example, all of our bacteria that are available in our portfolio are known to not produce biogenic amines. And so this is one of the reasons why I think that natural wines are such a big thing, because people have said that the sulfur dioxide is somehow a bad thing and people are allergic to sulfur and they get headaches, and so we would just want to use natural microflora. However, if you use indigenous microflora to conduct one or both of the biological fermentations, you actually have a much higher risk for biogenic amines, which produces quite a few compounds such as putrescine and cadaverine. And I looked for pictures of what this would look like. Putrescine is essentially the putrid, and cadaverine is rotting flesh. You also have histamine and tyramine that are also commonly produced, and histamine being something that can cause headaches as well as tyramine. So in an effort to reduce SO2 usage, because people think that they're allergic to it and it causes headaches, some winemakers have gotten into a situation where they're making wines that cause more headaches. So do you. Philosophy is important, and I totally understand that. Just generally speaking, the concern for wine quality does get greater when you're using native populations. So that's my topic on that. You can see, you know, we have H2S mousiness. It's a bit that, in my opinion, in the last 5 years, the incidence of mousiness has increased globally way more than what it should have. So I'm not sure the exact reasons, but I think it's some of this reduction of SO2 and reduction of using commercially available biologics. So moving on, after primary fermentation is done, I'm a big proponent of limiting the dissolved oxygen to less than 0.5 parts per million, and that pretty much stands for the rest of the wine's life. One of the reasons for this is if you are putting the wine through malolactic fermentation, malolactic bacteria do not require oxygen for their biologic conversion. Therefore, if you do have excess dissolved oxygen in the wine, it's now bioavailable for the spoilage organisms such as acetic acid bacteria, Brettanomyces, and so on and so forth. So in my opinion, before you go into malolactic, I think it is good to try to limit or remove the dissolved oxygen to this level. You know, in situations where you do have a high phenolic load and you do want to look at, you know, micro-ox and its effects, so on and so forth, I think that's a very valid thing to look at, but I think needs to also be done through proper analytics with the dissolved oxygen meter, volatile acidity, and looking at that consumptive rate of oxygen as opposed to any sort of prophylactic micro-ox. Post-malolactic, you can consider the use of chitosan products such as Bacillus, which is great because it's functional on gram-positive and gram-negative bacteria. So your malolactic lactobacillus strains, Pediococcus, acetic acid, so on and so forth. And then if you know you have a problem with Brettanomyces in your cellar, there's another formulation of chitosan called nobretinide that's has more activity on the Brettanomyces. So these are tools that we didn't have, you know, 20 years ago. So they're not an SO2 product. They're not animal derived. So they're really a good tool and they work quite well. Other enological products to consider during fermentation and fruit processing, enzymes during pressing. So if you do have high pH, you are concerned with the potassium that's in the skins. Perhaps you want to limit the extraction and thereby you want to process things faster. Enzymes can help you do this. You know, whether it's rot is a concern or just skin contact from a phenolic standpoint, enzymes can really help you speed up the pressing times. Tannins, you know, well known to limit the activity of lactase, help increase the oxidation protection. There's numerous reasons why tannins are good to use. Some people use oak chips; those work great too. So, you know, again, that's philosophical, but also, you know, sometimes you're forced into a corner when you have fruit that's got some rot that you want to try to combat. In pressing operations, I think one of the cool things that some people are doing is they're actually using a pH meter to monitor the pH increase during different press fractions. And they're separating those press fractions not only on taste and color, but also on pH. So, and then you can then have the ability to acidulate or manage those press fractions at a later date, and you handle things differently. Now, if you are going to acidulate the press fractions, the higher pressure press fractions, if you're going to consider acidulating them, just keep in mind that as you acidulate, you increase your perception of bitterness, astringency, and phenolics. So it is a balancing act. I do think it is important to choose a press based on its design and also what sort of pressing parameters it has. For example, like the Wilmus, which is what we sell, I think 1.6 is the highest pressure that it will go, 1.6 bar. Other presses that go much higher, they need to do that in order to get the yield based on the inherent design of the drum. So depending on what you're doing, your price point and your future plans, I think it's important to consider the different press designs out there. During cellaring and aging, again, I like, especially in high pH products, to limit the dissolved oxygen, because if you go all the way back to that first slide, we know that high pH wines are more sensitive to oxidation. So limiting that dissolved oxygen becomes much more paramount with higher pH applications. And again, if you want more information on this, contact me later. Look up some of the other presentations and articles that I've done on this. It's a super important thing in winemaking, if not one of the most important things for wine quality. The other thing to do is monitor VA on a regular basis. So what this looks like is, if you know you have a problem vineyard, or you want to have a robust QC program, you want to track VAs throughout the process. So this is, once you've crushed the fruit, take a VA number. Once you're done with primary, take another. Secondary, take another. Before and after barrel aging, so you can track to see where the VA is coming from. If you do see a spike, that allows you to then mitigate that problem. Use something like Akita Bacillus, something like that, to help mitigate it. And if you do have a VA problem, that allows you to, if it's in barrels, like to sequester those barrels, filter that wine, treat it differently than the rest of the batch. So I think monitoring volatile acidity is very important in high pH applications. And in general, the higher pH wines are more susceptible to microbial and chemical degradation, and therefore require more careful monitoring and handling. I say that, and it's kind of a generalized term, but if you're making champagne and you're at the 3 pH or lower, honestly, I've seen champagne cellars that are quite dirty, and their wines are great. And if you had the same cellar and made a whole bunch of high pH wines, there would be a much higher issue with faults and flaws. So it does really affect wine quality, your level of sanitation, but also your pH. So real quick, we know about bottle shock. I think there is something called barrel shock as well. And essentially, as you take a batch of wine and start to break it down to smaller and smaller unit sizes, so you take a 6,000 gallon batch and break it down to 160 gallon barrels, your exposure rate increases much higher to dissolved oxygen. As you move into even smaller containers, such as bottles, that it exacerbates things. That's why when you talk about like presses that have inerting capabilities and reductive, quote unquote, winemaking, you can have an issue with pinking and browning when you get to the bottle stage, because you've been very reductive the whole time insofar as keeping the wine away from dissolved oxygen, even on the juice stage. And when you have that exposure going to the bottles in this really high surface area, that's when you start to see some problems. Reductive versus oxidative winemaking is a whole nother presentation, but I just want to drive this home. As you break down a batch into smaller container sizes, your exposure goes up. Real quick on vessel construction. So I think this is important in high pH wines because of their proclivity towards microbial and oxidative degradation. So stainless, there's more controllable dissolved oxygen exposure. It's a more sanitary design inherently, easier and cheaper to clean and maintain. When you look into oak, such as oak barrels and plastic, there are some other issues that come into play. The porosity of oak and the ability for microorganisms to embed themselves farther into the stave is a huge issue. And in order to properly manage that, you really need to have the proper tools. So a barrel one that you hook up to a garden hose that just coats the inside of the barrel with water isn't doing much for you, if anything, other than just rinsing it. You do need to have something, in my opinion, that has a high pressure impingement hot water application to blast through those tartrates and actually remove a little bit of the wood layer if possible, and expose that surface to a cleaning chemical once you've done that. There are also TCA issues with barrels and oak products. Plastics, can also have issues. There's also leaching and scalping potentials as well. So there's some other things beyond just the cost per gallon that go into your vessel choice. When you prep the wine for bottling, I think it is important to do a proper sensory screen. This includes just smelling the wine and tasting it and see if there's any obvious flaws. But also, I like to run a cadmium, copper, and ascorbic to identify any volatile sulfur compounds. Obviously, when you use something like cadmium and copper, this is only from a olfactory standpoint. Please don't drink this stuff. Okay, those are heavy metals, but it will help you identify if there are volatile sulfur compounds. The ascorbic, what it allows it to do is to pull those heavy or high boiler, heavy molecular weight disulfides and pulls them back over to the mercaptan and H2S form. And when you do that, you can see if there's, you can identify which volatile sulfur compound it is. The other thing that this allows you to do is give something of a predictive idea of how the wine is going to age in the bottle. So if you run these tests and you get a lot of development of volatile sulfur compounds that you didn't know were there, if you put the wine in the bottle and the wine goes reductive, whether it's under cork or screw cap, it doesn't matter. Eventually, it will become reductive from a redox potential standpoint. Those volatile sulfur compounds will show themselves. So this is a great thing to do. And it's just a screen. Doesn't mean you have to use cadmium or copper or any of that stuff in your winemaking process. It just gives you some predictive power to know what's going on. Bench trials at this point with finishing cannons, I think, are a great idea, just to see is there some final touch I can do on this wine or not. You want to run the final wine chemistry panel, adjust as necessary, consider the legal and sensory limits. I'm specifically talking about SO2 at this point, and dissolved oxygen. So, if you go back to that second or third slide I had there in there about sulfur dioxide, you don't want to just add 125 parts of SO2 to hit your 0.8 molecular if your wine's 4 pH, because the wine's just going to smell like SO2 and you're likely to be over the legal limit. So sensory limit for SO2 is about 60 parts per million. Just know that any last minute adjustments you make, whether it's a blend, adding in a little bit of other wine, or adding a tannin, or any addition at that point can affect your colloidal stability. So when you're packaging high pH wines, I think you have to be way more vigilant with dissolved oxygen and total package oxygen. If you don't have a DO meter, which I think is an absolutely critical, not optional piece of equipment to have, you can monitor the free SO2 depletion after packaging to back into how much dissolved oxygen you either picked up and or had in the wine to begin with. And that ratio is about 4 to 1. So this is not a direct correlation, and I'm not going to go down into the weeds on oxidation and free SO2 binding with acetaldehyde and sugars and all of that. But in general, if you have a depletion of 4 parts per million SO2, that usually correlates with about 1 part per million of dissolved oxygen. So that can indicate how much bottle shock and how well you packaged. Lastly, sterile filtration or Velcorin for shelf stability. Your high pH wines are just going to have a higher propensity for issues in the bottle, such as Brettanomyces blooms, also bacterial issues. And I've seen this in the bottle, and I've talked to those winemakers, and they say, well, I don't like to sterile filter my reds. I'm like, well, okay, so you don't sterile filter the reds, but you have bottle blooms downstream. And I don't know that that's worth the trade-off, but again, that may be a philosophical thing. So it just depends on what you're looking for. In general, higher pH wines will have a shorter aging potential. However, if you are militant about monitoring dissolved oxygen, I think a high pH wine can age for many, many years, if not decades. So that's why I'm so imperative about monitoring your dissolved oxygen. Apart from that, that's about it. I think hopefully that was a good survey of high pH winemaking and kind of some of the critical control points to look at. There's all my contact info, the websites, my Instagram name, and that wizard is spelled wrong. Apparently I'm not a spelling wizard. But yeah, that's about it. If there's any questions, I'm sure there's a chat box we can do that in, or we can go offline with it.
Thank you. Yeah, no, that was great. Look, thank you so much. We have a question already. I think it's been already answered in the presentation, but here we go. Can we use SO2 in conjunction with Gaia?
Yes, I mean, you do have, I mean, SO2 is a broad spectrum antimicrobial. So with Gaia, you want to keep the total SO2 below 50 parts per million. If you have, you know, really high levels of SO2, it can be inhibitory to Gaia. But yes, in general, you can use it.
Thank you. I had a question about the dissolved oxygen. You're assuming you measured your DO and it's above 0.5 parts per million. What are the solutions? What can you do to decrease that?
One of my favorite methods is to use high purity nitrogen with a sparging stone to drive out that dissolved gas. So because nitrogen is so insoluble, it tends to displace the other gases that are soluble, such as CO2 and oxygen. I have plenty of information on how to do that, how to set up a tank, how to set up a sparging stone, the rates of sparging, and so on and so forth. That is, in my opinion, the easiest and most effective method. You can do other things like, you know, if you have a higher dissolved oxygen, you know, we know that tannins give us some antioxidant protection. So I've heard stories of some places in Australia, for example, every time they would rack, they would add like 10 parts per million of an inexpensive tannin that boosted its antioxidant potential. So you can use things like SO2 and tannins and things like that to increase the buffering capacity. So as you increase your tannin load and subsequently also increase your SO2 load, you can buffer more dissolved oxygen. In a light, delicate wine, that is going to be, if that's going to be more susceptible to degradation versus something like a Petit Syrah or Tannat, that's just going to have plenty of polyphenolics to buffer that dissolved oxygen. So short answer, sparging, long answer, phenolic load.
Thank you. We have a question about l'Alvigne. How early do you spray it, and do you spray it more than once?
Yes, so you spray it right about 5% of veraison, and then again, second treatment about 10 to 12 days afterwards, kind of weather dependent. So you don't want to spray it and then have a rain event right after.
Thanks. Does the use of ionis yeast also cause TA to be higher along the lower pH?
Yes.
Yes. All right. And I don't see any more questions from our panelists. So please, if you're logging off, please take 1 minute to do the survey. It helps me a lot. But I have a question for Luke before we leave. Philosophical question. How do you feel about malolactic fermentation in high pH wines?
Well, first thought is it's not a fermentation.
Yeah.
But that's a whole nother ball of wax.
Yep,
I think
yep.
terminology in the industry is a whole thing. But I think it lends a wine more stable. I know a lot of Texas wines have low malic to begin with. Mm-hmm. If it were me, I'd probably do a co-inoculation, and I'd hit it, with a good strong strain. And if there were issues with flabbiness or maybe flatness of the wine, and this gets into an area that I can't speak to with surety, but the biological malic acid that comes from the grapes is bioactive, right? This is why we can degrade it with malolactic bacteria. The commercially available malic acid, my understanding is it's a different isomer and therefore not bioactive. You have to verify that with the person that is selling you the malic acid, but potentially you can bring some of that malic acid flavor back after a malolactic conversion with exogenous malic acid that is not bioactive. So there's some tools there. I think there are many benefits of malolactic conversion beyond just the transfer from malic to lactic acid. There's color stability, there's some aromatic impact, there's some polysaccharides that are produced. There's a lot more that goes on there than just the biological conversion.
I'm a bit conflicted about it. Yeah. Sorry, I thought you were.
Yeah, no, I can drone on for hours, but yeah, what was your thought?
No, I personally think that it shouldn't be done, but I'm open to, you know, to hearing your thoughts on anybody else's thoughts. I think it's risky leaving the wine unprotected during that process, unless you do a co-inoculation, like you said. I don't know that the benefits outweigh the risks, especially here when the malic is so very low to begin with. There are ways of making the wine stable. You mentioned sterile filtration. That's one of them. But not everybody likes that. So yeah, I think it's a balance. But I, for one, tend to be on the no MLF side. But I hear you. I hear your argument.
Yeah. The other thing is if you leave, it's kind of that nutrient desert idea. Even though the malic is low, the spoilage organisms tend to be a little bit more voracious on consuming even the trace amounts of malic and fermentable sugars. And even some that the Saccharomyces don't really like, they'll even use some of those other sugars as well. So, you know, depending on how you're handling the wine downstream, you know, if you're coming off of primary, cleaning the wine up and like sterile filtering it and being very careful with it, yeah, I think the risk is pretty low. But if you're taking it and going straight to barrel and then doing a normal topping regime, and you don't have good barrel sanitation tools like a high pressure, high temperature, and ozone and all these things, and a steam generator, I think your risk is much higher from a contamination standpoint. And that residual malic, even though it's low from a generalized standpoint, I think it is one more carbon source for those spoilage organisms. So it's kind of, there's many different ways to look at it.
Yeah, you're right. One more question. Would you be happy to receive emails if a question arises later regarding this presentation and content? I'm not sure who this is aimed at, if it's you or me. My answer is yes, absolutely. I'm happy to.
Yep. I'm here too. Like I said, the wizard is spelled wrong, but if you want to Instagram me, that works too. You can text message, smoke signal, carrier pigeon. I don't care how you do it.
That's all we have for now. I don't see any other questions. So again, if you're logging off, please take 1 minute to take the survey. Thank you very much. Thank you, Luke, so much for being here today with us, for giving this presentation. Super informative as usual. I appreciate your time and effort. And to everybody else, I say goodbye, and we will see you next time. Have a good day, everyone.
Thank you.
Bye-bye.